Hi, I'm Matthias Murray. For my summer internship with LexisNexis, I worked on applying HPC systems text vectors to SEC filings. SEC filings are the documents that the Securities and Exchange Commission requires publicly traded companies to submit in order to keep their investors and the general public informed. We focused on 10K and 10Q forms, which are very important forms required every quarter and every year to keep these updates coming to investors. They include a lot of text that can be analyzed with natural language processing techniques. This can include notes directly from the highest levels of management, from the CEO, from CTO, saying how they think that their products are going to do in the coming months or how they've been doing in the previous months. But it can also include required statements that might be repetitive from filing to filing. The ones that do change can have sentiment from these people in the know. They can have negative statements, they can have positive statements. And part of the goal for this project was to test whether there is meaningful signal in that sentiment to predict the change in stock prices. So the flow down here shows the general project. And once data was obtained from the SEC's website and from databases containing stock prices historically, the SEC filings were parsed and extracted, and the labels were also cleaned up. The text was separated into sentences so that it could be used in the TextVector's model, which expects a list of sentences to be trained. And once we have the TextVector's model, it actually translates text, any sentence, any word, into a vector. So everything is embedded into n-dimensional space. That means that we have a quantity instead of a word. And if we pair a quantity with a binary label, 0 or 1, depending on whether the stock went up or not, you can then put that into a model, binomial logistic regression, classification forest, random forest, even support vector machines, lots of different things. And you can try and then have a trained model that's capable of predicting whether new vectors from filings are likely to then be stocks that go up or down. So we were able to test these on out-of-sample stocks, filings that were not part of the training process, and these results are shown down here. The main metric that we focused on was POD and PODE. That describes how much better the accuracy performed than a naive solution. PODE is the main one to think about. This is just how much better did it perform than guessing the largest class. So you've got a bag of marbles, 10 marbles, 6 are red, 4 are blue. If you guess red every time, you're gonna have 60% accuracy, but it's a naive solution. If you wanna be smart about guessing the marbles, you wanna really have reasons other than just red is most common. So if we did better than guessing the most common choice, then we actually got signal. And it turns out that when you create separate models for each industry sector that we examined, finance, healthcare, energy, etc., most of them were able to get PODE scores that were more than 0 for both binomial logistic regression models and classification forest documents. But this is only for direct document. So this was by taking all of the sentences in a document and averaging them together so that you get one document vector and ultimately then modeling on that document vector. Something that was interesting was S&P labels weren't always more representative. So what are S&P labels? That's not just whether the stock went up or down, but whether it was up or down compared to the broad market. And we basically think that might be because a business could be doing well, but if they know that the economy is doing poorly, the sentiment could be negative. And so that kind of effect can potentially mean that the absolute price change is going to be more related. The speed was fantastic from HPC systems. We were able to perform an extraction, a read, and a model training that was for 50,000 sentences, roughly 20 gigs of data in 5 minutes. And that was pretty phenomenal. So we're very happy to have been a part of this. And yeah, this was a really great project to have worked on. Thank you.